Welcome to this session of Loose Talk About Physics. I've been wondering about a little bit of different stuff here, where basically it's a lack of working dimensions. I'll also talk a little bit about tunneling, wave-like pattern, and Planck length. Basically, it's like if you have these ones here equal to the Planck length. If you convert it as one Planck length, basically, I'll say that if you combine two dimensions with one Planck length at the y-axis and one Planck length at the z-axis here. As you know, it's the smallest length possible to have. That's the Planck length. But a combination of one cathete and smaller and one cathete equals root of 2. So that's pretty much more than the Planck length. So let's say something happens in the subatomic world where this one here suddenly becomes 0 something. Let's say 0.99992. According to that the Planck length is the smallest thing we have, this dimension breaks down. So something that could be described in 2D, let's say the x and y axis here, with one Planck length up and one Planck length going this way, breaks down to 1D. But this 2 here doesn't break down. But what will happen when something like that happens? Well, if this direction breaks down due to a value less than the Planck length, it will tend to travel in this direction where the Planck length still holds. And of course also this combination of the two one-dimensional x and y to a plane, it's also possible to travel there. But what happens? Let's say a particle starts here and going like this in the path like that, and suddenly here something breaks down, so 2D goes to 1D because of this violation of this Planck length here. The path of the electron will go like this, and it's here why the wave-like pattern of the particle is obvious. When this two-dimensional breaks down to one-dimensionals, well, and suddenly comes back again. Let's say it all gets fixed. The electron in this path will tend to take the same direction as it had before, but not the same. It's the same because this y dimension broke down to something less than the Planck length. When that happened, when it broke down, this became 0.9, the Planck length. It had to hold. The only remainder of that could prove this dimension was the root 0.2, who is a combination of x and y here. And likewise, 3 dimensions could break down to 2 dimensions, where you have in one cathete root of 2 and 1. It's the smallest possible root here. This will be more than that. So in a subatomic world, 3 dimensions break down to 2 dimensions, 2 dimensions break down to 1 dimension. In some way you could say that in the 1 dimension you have all the others, the 2 dimensions and the 3 dimensions. And this, I think, has something to do with tunneling, where something goes through a wall. Let's say the dimension towards the wall breaks down, and the particle or electron or something takes the other path. It's some like and it still is. If 2 dimensions break down to 1 dimension, this will be the path, a line, and actually this curled up path here could be a straight line, and a straight line can look like this when you take into account that 3 dimensions could break into 2 dimensions, 2 dimensions break down to 1 dimension due to that you have something that becomes smaller than the Planck length. And this could also seem like something vibrating. So I think in some way that when you talk about length lower than the Planck length, you cannot describe that as a dimension. So, but you have the others. So I think this creation and destruction of dimensions could explain physical properties like tunneling and also wave-like patterns that are interference of something that goes in 2 dimensions. And string theory. So here you have the smallest possible length, 1 Planck length in the y-axis for a 2-dimensional cage, and 1 Planck length in the x-axis. The distance between them is somewhat more, it's the root of 2 Planck length. If this breakdown, the particle will have to do with this length here, and this is the combination of y and u. So let's say it gets up again, it has gone through the wall where it should have stopped if this direction was there. Let's say it goes through the wall in this direction, but that on a 90-degree angle straight through, but this direction does not exist, then the wall that the particle will try to go through is not described physically in that direction, and suddenly it pops through because there is no such thing as the y direction. It has broken down from 2D to 1D, and suddenly afterwards it might get this y here in the plane might be created again. That could explain tunneling effect, because maybe like in the sun where hydrogen combines to get helium by the tunneling effect, at some convenient point you take out this y direction and 2D becomes 1D, described by this one, the small things, and suddenly afterwards it has gone through this and has not gone through this because this dimension didn't exist, the y dimension, and suddenly it appears, but now the particle is in the right place and can combine like 2 helium atoms to become 2 hydrogen atoms to become a helium atom. So tunneling, after my view, is possible.